Hello and good morning to everyone. Our today's lead code question is 1081, that is smallest subsequence of distinct characters. So basically in this question we are given a string s, and now what we have to do is we have to return the lexicographically smallest subsequence of s. But there is a condition that this subsequence should contain all the distinct characters of s exactly once. So whatever the subsequence that we get, it should contains all the distinct characters. It should contains all the distinct characters of s at least one time, right? So let's see the example. So in the first example, our string is bcabc, right? So what are the distinct characters? So distinct characters are a, b and c, right? So now in what order should we contain a, b and c such that the subsequence that we get should be lexicographically smallest, right? Lexicographically smallest, this is what we want to. So suppose if we get bca, is this the, so we get bca, we can get cab, cab, we can even get abc, abc. So which one is the lexicographically smallest among these? So abc is the lexicographically smallest, so that is our answer. Now if you see the this example here, what are the distinct characters? Distinct characters are a, b, c and d, right? So here if you see, we can get this string a, c, d, this subsequence a, c, d and b, a, c, d and b, that is our answer, right? So let's see the constraints. So our string length is 1000, right? So that means we have 10 to the power 3 characters in the string, and all the characters are in lowercase English letters, right? So let's move to the approach part. So basically what we need to create a subsequence which contains every distinct characters exactly once, and the subsequence should be lexicographically smallest. This is what we want, right? So the first thing that comes to my mind is like, whenever we get a character, we get a character ch, so we'll take two decisions: either we take the character or we skip the character, right? But this thing doesn't give us like what you call, doesn't give us the true decisions. Like this will not give us true decisions, because sometimes it may be possible that we already have taken a larger character, and later we discover a later we discover a smaller character than the character that we have already taken, but the smaller character should come before that character, right? So instead of deciding that at any point we should take a character or skip the character, what we'll do is we'll decide that whether can we remove the previously taken character, right? So let's see an example to understand this, right? So see here, we have c, cb, ac, dc, bc, right? So the distinct characters are a, b, c and d, a, b, c and d. So all these characters should be present at least once in our answer. And now let's say we already have taken c in our answer and then b in our answer, and now we are present at index number 2, and our current character is a. Now if we see this character, current character a is less than the character that we have taken, that is b. So now our question is, can we remove b from our answer, right? Can we remove b from our answer? So the answer is yes, we can remove it, because another b exists in the string later, right? So see here, we have another b, right? We have another b. So even if we remove this b, then we can take this b later, right? So we we removed this b from the answer. So now we are left with c, and our current character is a. So now we check both. Now again c is greater than a. So again the same question, can we remove c from the answer? So again let's see whether c is present in future. Yes, c is present in future, so we can remove c also. We can remove c also, because another c also appears in the future. So now what we have done is, we already have C and B in our answer, and our current character was A. So now instead of we keeping C and B, we remove both of them and then we have added A. So basically this will be our main greedy idea, that whenever we get a character CH, we'll take the top character from the stack and then check both. Now if a top character is greater than the current character, then we check, then we see whether we can remove this top character or not, right? And if we can remove the top character, then we remove the top character and then check the next top character and so on. So that's our main idea. So let's see when we can remove the top character from the stack, right? So let's say now our top character is X and our current character is Y. Now we have to decide that whether can we remove X from the top of the stack or not. So basically we can remove X if the given three conditions will satisfies. So the first condition is this X should be a bigger character or a greater character than the current character, right? So this is the first condition. Now the second condition is that if, so right now we are removing X from the answer, but it is given in the question that all the distinct characters should be appear at least one in the answer. So if we are removing it currently, then it should be present in the future. It should be present in the future so that we can take the X at that time. So the second condition is that if X exists later, right? So because if X is not present in future and then we remove it, then we lose the character, right? And then we cannot include that in the answer. So that our condition that adding all the characters in the answer will be false, right? So this is the second condition. Now the third condition is that the current character y, it is already not present in the answer. It is already not present in the answer, right? Then we can uh, remove the top character. So what are the third condition? First condition, X should be greater than Y. Second condition, X is our top character. X should be present later. And third condition is Y is not in answer. It's not already taken in the answer. So we check all these three conditions to remove the top character X, right? So we'll try to understand the whole approach with the help of an example. So we have taken this string CBACD right? So first thing that we'll do is we'll compute the last occurrence of every character, or last occurrence, or we can say last index of every character where they are appearing. So see, A is appearing at index number 2, B is appearing at index number 6, C is appearing at index number 7, and D is appearing at index number 4. So these are the last indexes of each character. Now what we'll do is now we'll process each character one by one. So we have taken a stack which is initially empty, and now our current character is C, and our stack top is, there is nothing in the stack, so top is empty. So we'll directly push the correct character. So now we have C in our stack. Now our current character is B. Now we compare the top character is C and current character is B. So now we check, can we remove C? So we check C is greater than B, right? And another C also exists in the future in the string. So we can remove the C from the top and then we'll push the B, right? So now we have removed the C. So in our stack we are only left with B, and now our current character is A. Now again we check, can we remove B? So again the same thing, B is greater than A, another B exists in the future, so we remove the B and then we push A. So now in our stack we have A, and now our current character is C and our top character is A. So the first condition, that top should be greater than current. So this condition is false. that we cannot remove the top, so we directly push our current character C. So now in stack we have A and C. Now our current character is D. Again we compare top character and the current character. Again our top character is smaller than current character, so again we push our current character. So in stack we have A, C and D. Now our current character is C and our top character is D. So can we remove D? Can we remove D? So first condition, D is greater than C. First condition is satisfying. Second condition, we check, is D present in future? Is D present in future? So the last index of D is 4. Last index of D is 4. So even D is not present in future. So the second condition is also false, that D is not present in the future. Then we check the third condition, that is our current character not in the answer. So we can see current character is already in the answer. So two conditions are false. So basically our current character is already present in the answer, so we skip it. So we do not include the current character in the answer. Then we move to the next index. So now the current character is B and the top character is D. So D is greater than B, right? But the thing is that another D doesn't exist in the future, right? So if we remove D here, if we remove D at this point, then we will not get any chance to include D in our answer in the future. So we cannot remove this D, right? We cannot remove it. But so if the top element cannot be removed, then everything below it must also stay as they are present. So we directly push the current character B in the stack, right? So now we have A, C, D and B in the stack, and now our current character is C and our top character is D, but C is already present in the answer, so we skip it. So we get our final answer, which is A, C, D and B. So basically this is the subsequence that contains all the distinct elements of the string and also lexicographically smallest, right? So we get our answer, right? So let's move to the code part. So in the code part, as we already discussed, first thing that we need to do is we need to find the last index of every character. So first thing that we are doing is finding the last index of every character, and then we have taken two things. One is a string st. So basically here using this string we'll simulate the stack, right? We'll simulate the stack. So in stack we are checking the top operation or top element. So in string we'll check the last element. And there is another vector in stack that will check whether a character is already taken in the answer or not. So if in stack of some character is true, that means that answer is already present in the answer, right? So what we'll do is we'll take each character, and then if that character is already included in the answer, that means the in stack value of that character is true, then we skip that character, right? We don't do anything with that character. But if it is not already present in the stack, then we take the top element, and if a top element is greater than the current character, then we remove the top element, right? So we keep removing the top elements, right? And to remove the top element, we'll check if the last index of that removed element is greater than the current index. That means that top character is present in future with us. So that we can include it at a later point in our answer. Then only we remove that. And once we remove a character, then we mark that character as false, that it is not present in the answer, and then remove that character from the string. And then once we remove all the possible top characters, then we include our current answer in the string and then mark that character as true, that it is present in the answer. And once we do this for all the characters in our input string, then we return our final answer, that is a subsequence with the all the distinct elements and the lowest lexicographically smallest, right? So I hope I'm able to explain you the solution properly. So if you like the video, please make sure to like, share and subscribe the channel. Thank you.